Okay, so this is going to be a Oxford book A1, numbers 19 through 25. And these are all located on page 34 in the textbook. A few multiple choice to start off. So they give us a diagram for number 19. They say trajectories of two projectiles launched from the same height. The projectiles reach the same maximum height. Which quantity, God, I can't talk, has the same value for both projectiles? So A is initial speed, B is time of flight, C is horizontal component of initial velocity, and D is speed at maximum height. So a couple of these you can rule out right off the bat. They can't have the same initial speed. If they did, then one of them would not get to the same height. One would be lower. One was fired at a lower angle, wouldn't get to the same height. Time of flight, possibility. Horizontal component of initial velocity. No way could they have the same horizontal component. This one clearly has a bigger horizontal component. And speed at maximum height. This one must have, at their max height, the vertical speed's got to be 0. So clearly this one must be moving faster horizontally. So it can't be that one. So it's got to be B. And just remember from what you've read in the book, the vertical velocity is what determines how long something's going to be in the air if you're firing back to the same height. If you're firing off of a cliff and it's going to come down, then the height of the cliff comes into play too in determining how long the object's going to be in the air. But the horizontal speed of an object has no effect whatsoever on how long it's going to be in the air until you start to talk about orbital mechanics. If you fire something fast enough, technically the curvature of the Earth would be changing. But the answer for number 19 is B. For number 20, an arrow is fired horizontally, love that, from a height h and travels a horizontal distance s before striking the ground. So I did a little diagram here. Another arrow is fired with the same velocity and travels a horizontal distance of 2s. So the only way for that to happen, to go 2s with the same horizontal velocity, and it was fired horizontally, is if the height is higher. Okay, so I just wrote it out here. Travel 2 seconds with the same initial horizontal speed. The time must double. All right, so the relationship between h and t is h is proportional to t squared. If you remember the book, actually I have it right down here. S equals ut plus 1/2 at squared. So the displacement is proportional to time squared. So if you want to double s, then if you want to double t, my apologies, then h has got a quadruple. So that's why the answer is D, 4h. Number 21, a stone is thrown vertically downward from the top of a tower with an initial speed of 4 meters per second. Here's my diagram. Stone hits the ground 1.9 seconds later. They gave me a ton of information here. What is the height of the tower? So always write down your knowns. G is equal to 10 meters per second squared. I labeled down as positive. U is going to be 4 meters per second. Time is 1.9. You want H or S. I call this is height, but height is displacement in this case. So just use this equation. Displacement is initial velocity times time plus 1/2 acceleration times time squared. When you work that out, you get 25.85. The only answer remotely close to that is D. Now, here's our first one with two-dimensional kinematics. Okay, so just a quick review. Remember, vertical has acceleration, horizontal does not. We will not take into account air resistance horizontally. So make sure you keep your variables separate. There will be some overlap. For example, time is going to exist in both of these. In this case, the time to go from here to the ground would be the same as the time to go from this point right here to that point. Okay. So, but because we have more variables in the vertical direction, we know h, we know g, and we know the initial velocity in the vertical direction is 0 because it's being fired horizontally. We can actually plug that into our equation here. Now, granted, they didn't give us any numbers, but they said that the height of your table is h. Just consider that a number. They said the initial velocity is v. Just consider that a number, but it's horizontal. So that's going to go into our horizontal side here. Yeah, and so then you can figure out that the initial vertical velocity is going to be 0. So u for the vertical will be 0, which cancels out this term right here. So you can just say h is equal to g over 2 times t squared. So solving that out, you get time is square root of 2h over g. And now you can put that up into the horizontal knowns. And then to find the horizontal distance, d, Distance is just velocity times time. It's a constant speed in the horizontal direction. So that makes our equation very, very straightforward. So you just say v times the square root of 2h over g. And that answer was C. For 23, we got our football player kicks a ball into the air. The ball reaches its maximum height at 0.9 seconds after the kick, and its horizontal displacement at that instant is 16 meters. So again, always draw yourself a little diagram here. I have my vertical and my horizontal. So I labeled these a little better this time, I should say. So my time up, which is my t at 0.9, because technically time is 0 here, it's 0.9 there. If it's going to a level playing field, it'll be 1.8 here. So my time up is 0.9 seconds. My velocity at this point in the vertical direction is 0, because that's its maximum height. So its maximum height, it goes to a velocity of 0 instantaneously, and then it'll start speeding up on its way down. And my acceleration, I'm going with down is negative, up is positive. So because I have this, it allows me to answer A very quickly. A asks, what's the vertical component of the initial velocity? So let's find the vertical initial velocity, which will be u. So v is equal to u plus at. 0 is equal to u minus 10. I'm using gravity as 10 times 0.9. So we must have an initial velocity in the vertical direction of 9. They want its initial speed. To find its initial speed, you have to know both the vertical and horizontal components of the speed. We know the vertical component is 9. Over here, we knew the displacement in the x direction. Notice I called it s sub x. You could call it s sub h, horizontal, whichever you want to use, is 16 meters. And we know that it covered those 16 meters horizontally in 0.9 seconds. So we can figure out our velocity by just taking 16 over 0.9, and that gives you 17.8. So the answer for A is 9 meters per second. For B, we have 17.8 meters per second horizontally plus 9 meters per second vertically. When you add those up using the Pythagorean, you get 19.9 meters per second, or with sig figs, because they only gave us 2 sig figs in all of these things. Technically, it should be 20 meters per second. For C, the angle to the horizontal which leaves the ground, you have the horizontal component and the vertical component. So just like the previous problem, use an inverse tangent. Theta is going to be tangent to -1 of 9 over 17.8. I got 27 degrees when I did that. And D, it's maximum height. So maximum height, so essentially you want S here. So that would be the vertical direction. And you know pretty much everything. You know the initial speed is 9. You know the time is 0.9. And you know the acceleration. So just plug into this equation here. And you could break it up and you could say the initial speed is 0. You don't care about the final speed, but if you go from here down, that would give you the exact same displacement. It would be a negative value, but all they're asking for is the height. So that's technically a scalar value. And what that would do is it would get rid of this term right here because your initial speed would be 0. And you just have negative 4.05, which is the same as 4.01 up, okay, when you're talking about a distance. All right, 24. This one's a little bit trickier. Just got to be careful about it. So we have our tennis player serves a tennis ball towards the net, and this was actually an IB problem straight off the test from like 2018. The ball leaves the racket horizontally at a height of 2.7 meters above the ground, so I just labeled initial 2.7 meters. The net is 0.9 meters high, so I put my net over here 0.9 meters high, and a distance of 12 meters from the player. So I just have this right here, and determine the minimum initial speed of the ball so that it passes above the net, all right? And they want the initial speed of the ball, okay? Now, they did say it's fired horizontally, so we got to find this horizontal speed. So horizontally, all I know is it's got to cover those 12 meters. I don't know how much time yet. I shouldn't have put that, well, I should have something around that letting you know that I calculated that because time was determined by the vertical direction in this case. Now, how do we determine the time? We first got to figure out how far can this thing fall? Well, it can't go below 0.9 meters before it gets to here, so it can only fall 1.8 meters. So I have a change in S, which is the displacement, is negative 1.8 meters. My acceleration is negative 10 meters per second squared. My initial speed in the vertical direction is 0. So I just found the time to fall in 1.8 meters. Or sorry, time to fall 1.8 meters. So my change in S would be my distance that it's fallen. UT plus 1/2 AT squared. This term cancels out. There is no initial velocity. So negative 1.8 is equal to 1/2 times negative 10t squared. I got a time of 0.6 seconds. That's how I got that 0.6. And then to find the horizontal speed, just take 12 divided by 0.6, which is 20. So if the ball is not struck at 20 meters per second, a minimum, then it will definitely hit the net. And most tennis players hit it much faster than that. That's like 45 miles an hour. All right, so this was the most complex problem. Well, let's just take a look at it for a second. Olaf throws a dart with a speed of 9 meters per second and an angle of 4 degrees above the horizontal. As soon as I see a 4 degree and something like that, and I know that I'm going to be dealing with horizontal and verticals, I usually just break it up. Unless I can switch my reference frame, but in this case, I could not. So I have 9 at 4 degrees. I just broke it up into 9 cosine 4 plus 9 sine 4. Please make sure that you have your calculator in degrees when you do this. So then I went to my horizontal and verticals, and I know my horizontal direction, I got 8.98. And my vertical direction, I've got my initial velocity, which is 9 sine 4, was 0.62. My acceleration is negative 9.8 meters per second squared. Sorry, I forgot the squared there. And my displacement is going to be negative 0.25 meters. Please make sure you recognize that if you labeled this as positive, your vertical speed as positive, then your displacement has to be negative because it fell below the initial height of the dart. Okay? So you got to establish up and down which one's positive, which one's negative. You can assign it, but just make sure that you stay with it through the problem. So it says, show the time of flight of the dart is approximately 0.3 seconds. So this was complex. This would be a place where you would actually use the Pythagorean theorem if you wanted to. I usually don't. I usually just solve for the final velocity of the ball, or sorry, the dart in this case, because I just don't like busting out the Pythagorean theorem. But you could use it. You could just say, going back to this equation right here, S is ut plus 1/2 at squared. You technically have the initial speed, you have the acceleration, and you have the displacement. Because notice what you've been given: displacement, acceleration, initial speed. You could use that equation, and then it is a quadratic. Again, I just choose to find the final velocity first using v squared is equal to u squared plus 2ad, and that should be 2as, sorry. So when I do that, I find my velocity, because I had to take a square root. It's either 2.3 meters per second or negative 2.3 meters per second. I have to make the determination. Because I know that it's falling at this point, I have to go with the negative 2.3 meters per second. You just have to use your physics thinking on this. So now I'm going to find the time, because I now have the velocity. So I can say v is equal to u plus at. If this isn't negative, you're going to be way off. So I got negative 2.3 equals 0.62 minus 9.8t. And so when you subtract 0.62 from both sides, you get 2.92. And then 2.92 divided by 9.8, both negatives. The negatives will cancel. You get 0.3 seconds. Otherwise, you'll get a negative time. And if you get a negative time, that usually means that you were not careful with your signs somewhere in your vertical direction. So just go back and check those. All right, calculate the distance between Olaf and the dartboard. So that one's pretty straightforward, because once you know the time, which they gave you technically at 0.3, you can just say horizontal distance is strictly determined by horizontal direction. So distance is velocity times time. You know the velocity, you know the time. Distance got to be 2.7 meters, which is about 8 feet. Then we want the speed of the dart when it hits the bullseye. So that's just going to be the sum of your velocity vectors when it gets to the bullseye. We know the horizontal is not going to change. It's 8.98. The vertical is going to be 2.3 down. So it doesn't matter negative. I'm just saying you're just going to add those two up. So our direction would be 9.3 meters per second when you add those two up using the Pythagorean. And they only asked for speed. They didn't ask for the theta. That's why I didn't calculate it. So that's the speed, is 9.3 meters per second. And finally, sketch the graphs to show the variation with time of the dart. So the horizontal velocity with time, I called it Vx, and that was just going to be 9, and it's consistent, or 8.98 if you would like. The vertical velocity is going to be a little bit different. It's going to start at 0.62 right there, and then I figured out what the intercept is going to be by just dividing by 9.8, because that's how long it's going to take to stop. because what you do is you set that equal to 0, velocity equals 0, 0.62 minus 9.8t, solve it out, and you would find out that it's 0.63 seconds. So that would be my intercept right there, 0.063 seconds. And then I didn't take it all the way out to the 0.3 because it'd probably be over here. But I did just note that the slope has got to be negative 9.8 meters per second squared because it's a velocity versus time graph. So the slope of the graph gives you the acceleration of the object. And hence, note the slope here is 0. All right, I hope this was helpful.